Okay, so welcome to part 6 and the final part of this chapter called linear maps. So part 6 we are going to talk about projection. Okay. And this part is going to be divided into two sections. Section A, orthogonal projection into a line. Projection into a line. Here as well, I'm going to do the lecture and the tutorial all together. Okay, so let's start with the introduction. Okay, so let's say we have the following vector v. Okay, and let's say we have the following line. Okay, S, the line is let's call it S, or you know, the line L. Okay, and let's say we want to decompose or orthogonally project this vector. Okay, so this vector v can be decomposed into two vectors. Okay, the horizontal vector and the vertical vector. Okay, and for the horizontal vector, let's call it Cp of S. Okay, and why is Cp? Cp is the scalar. Let's just use Cp for the scalar, okay, and S for the direction vector of L. Okay, so let's call the horizontal vector Cp of S. So based on the parallelogram rule, for adding two vectors, we know that this vector is going to be V minus Cp of S. If you see, is that okay? So our line L, this line L there is spanned by okay, so the line L is the span of the vector S. Okay, the line L is spanned by the vector S. So yeah, C is just a constant such that the C is an element of R. Okay, so based on the parallelogram rule, let's try to calculate the Cp. Okay, we know that the horizontal and the vertical vectors, they are going to be orthogonal. Okay, so V, that's the vertical vector, V minus Cp dot S is orthogonal to S, of course. That means V minus Cp dot S, okay, dot the vector S is going to be 0 because the vertical vector is orthogonal to the line and the line is spanned by the vector S. Okay, so we have seen how to do okay, we can easily here we know that dot vector multiplication distribute over vectors addition. Okay, so that means after calculation, if you remove the bracket, Cp is going to be equal to, or if you want to let me work it out completely, so we have V dot S minus Cp dot S, or multiplied by S dot S. Okay, that's scalar. This is a vector dot, and this is scalar multiplication equals to 0. So that means minus Cp S dot S is going to be equal to, or just Cp is going to be equal to V dot S. Okay, so that means CP. Okay, so if you don't want to get confused with CP and dot, okay, so CP multiplied by S. Okay, CP multiplied by S there. So CP is going to be equal to V dot S over S dot S. And the CP is that fraction of the vector V into the line L. Okay, it's the fraction of the vector V into the line L. So that's CP. Okay, this will lead us to our definition. Number 2, definition. Okay, it says that the orthogonal projection of V into the line spanned by a non-zero vector S is the vector, so is the vector, okay, so it's the vector CP multiplied by the CS, okay, the CP, so is that portion of V into the line, okay, multiplied by the vector S. So, and we have seen CP, what CP is, so it's going to be that vector, we are going to call it, okay, projection of V into the line spanned by S is going to be equal to V dot S over S dot S, okay, this is the CP, this time multiplied by the vector S, okay. Here, that's what we have there, okay. So now let's do the tutorial on the next slide. Okay, so tutorial question 3. Example. So we have example says the following, says find the orthogonal projection of the vector V given as minus 2, 1 into the line y equals minus 3x. So that's our line, okay. Now what we need to be able to do that, we need okay, we have the equation of the line, we need to have the vector that is spanning the line, so we need S, okay. So let's start the solution here. We have L, our line L is X and Y, such that Y equals minus 3x. So this can be written as instead of x we have minus 3x there, instead of y, okay, so this should be, instead of y we should write minus 3x, so this is x minus 3x which is equal to 1 minus 3 multiplied by x. Okay, such that x is an element of R, or x is free. Is that okay? So the line is being spanned by this vector. That means the vector S equals 1 minus 3. Okay? So that's the direction vector. So this is step 1. Step 1, finding S, the direction vector of the line. Okay, so step 1. Step 2, now we can just apply the formula. Step 2. Okay, finding the orthogonal projection of V into the line spanned by S. Okay, so we have seen the formula. The orthogonal projection of V into the line spanned by S is equal to, the formula is there, V dot S. So we have V dot S over S dot S. Okay, so that's the portion of the line, of the vector into the line, and then we have the vector S there. Okay, so this is going to be equal to, our vector V is minus 2, 1 dot S, there is 1 minus 3 all over 1, 3 minus 3 dot 1 minus 3, all multiplied by the vector 1 minus 3. Okay, so this is equal to the dot, so minus 2 minus 3 minus 2 minus 3, okay, over 1 plus 9. Okay, we know how to do the dot product. Okay, 1 minus 3, this is a minus 5 over 10, 1 minus 3, which is a half, which is minus a half, 1 minus 3. So we can say this is finally minus a half and 3 over 2. Okay, so this is the projection of, so orthogonal projection of the vector V into the line spanned by the vector S. Okay, so we are going to stop here and we will continue in the next video with the Gram-Schmidt orthogonalization. Okay, thank you.